Lightweight, portable, innovative. TESCO's 6330 meter site analyzer is the most versatile and complete tool for testing the entire functionality of transformer-rated metering installations. Contact us today for a free demo. So today we have another edition of TESCO Tuesday, and we'll get started with traditional ratio, burden, admittance, and Demag testing. This is a two-part session because there's so much content to cover, and we are anticipating a lot of questions with this, so we divide it into two sessions. We'll have a short presentation today and follow up with a lot of questions and kind of chat at the end. And then next week, we'll kind of dive into it more detail, more things like that. So maybe some of that's covered today, but we're also going to do it again next week as well and just get into more of that detail is there. So today's also unique because Rob Reese, who's our Midwest Regional Manager, is actually giving the presentation today, but he is actually at a meter school today. It's the first meter school since last year. It was actually the last meter school we did last year before everything shut down. So they invited us back this year. It's very small, and it was the first time we went out and we did a couple presentations today, so that's exciting. It's out in Western Pennsylvania. So Rob, I do believe you are on the line. Can you hear us okay? And are you there?
Yes, I am.
Excellent.
Hey,
okay.
everyone.
So he's going to be joining us live now, but we did pre-record the session just to make sure we were able to give this to you guys today. It's only about 17 minutes long, and then we're going to open it up to presentation or to Rob to answer any questions, and we can go back to different slides. There's a couple links at the end that we will share with you guys as well. And again, just before we start, we have some general guidelines. We ask that you mute yourself so that we can hear the presenter and others if they have questions. You can always type them into the chat, and we'll address it for this session after the pre-recorded one. Typically, we answer as we go. But again, it's kind of short, so we have a long Q&A at the end. And then if you need to unmute yourself to ask the question at the end, just mute yourself again, because sometimes it picks up background noise and it's hard to hear others. And all you guys know, at the end of each session, we post a copy on our website, and we'll send out an email if you're registered. You can find it also at tescometering.com/TESCO Tuesdays. And I think with that, we are ready to go. So I am going to, you guys should all see my screen here, and I'm going to hit play. And we'll see you guys in a little bit.
Hey, good morning, everyone. Thanks, Andy, and thanks, everybody, for joining us today. Like Andy said, I'm Rob Reese, Midwest Regional Sales Manager for TESCO. And for the next little bit, we will be discussing CT testing, specifically burden, ratio, and admittance testing. To start off here, as most of you are fully aware, we have literally dozens of meter forms available per the ANSI specifications. But overall and in general, and transformer rated meters. As you can see, there are a lot more transformer rated meters than the simpler self-contained. We'll spend the next couple of minutes going through the difference here, specifically for any newer folks that might be on the phone here. So we'll start with self-contained meters. Self-contained meters primarily used in relatively low current applications and primarily residential installations. A couple of examples are the 1S, the 2S meters. And like I said, we're dealing with relatively low current in these installations, so therefore, putting a meter in series with the customer load is applicable. The meter can handle all the load delivered to the customer site. Alternatively, before we go further, here's a couple other pictures of a residential installation with the masthead, the service wires, the drop down to the electric meter, and on to the customer's load center. Alternatively, for your commercial industrial customers and installations where you might have relatively high current flowing to the customer, you would use a transformer rated meter such as a 9S. In this case, putting a meter in series with the customer load is not applicable. They cannot take that much current to be able to handle that much current. The meter would have to be the size of a Volvo. So putting the meter in series with the customer load in high current applications is a big no-no. So, and so therefore we have transformer rated metering, or like I like to call it, indirect metering, where we utilize a series of PTs and CTs to ratio down the customer voltage and current to levels that the meter can safely and accurately measure. Typical components of a transformer rated metering installation include your PTs, the CTs, the meter, a pre-wired meter enclosure, and in most cases, a safety test switch. Now we will discuss burden, ratio, and admittance testing in further detail. For these test examples, we will use an example application here, a 9S meter installation, which utilizes 3 CTs, 1 for each phase, and their secondaries run to the transformer rated meter. Everything that you need to know for testing a CT is located on the faceplate of the CT, just like in meter accuracy testing. You will have a ratio specification. A ratio, for instance, using this example, a 400:5 ratio will produce 5 amps on the secondary when 400 amps are applied to the primary. You will also have a burden rating as well. In this example here, it's kind of hard to read, but on this faceplate, it says 0.3% of burdens of 0.1 to burdens of 1.8. The burden specification is a little more detailed than the ratio specification. The burden range present in the secondary circuit that the manufacturer will guarantee their CTs will accurately function in regards to the ratio specification. And we'll get back on specifically how to test that. So for a ratio test, it's pretty straightforward. You just take a measurement of the primary current, a measurement of the secondary current from the CT, typically through the safety test switch, and calculate the ratio. You can use a simple fluke or AMC style clamp handheld meter. But one caveat that you need to be aware of and be considerate of is if there's any time between the measurement of the primary current and the secondary current, if you have a fluctuating load, that might throw your numbers off. So various specified custom ratio test units on the market take these two measurements simultaneously, thus negating a fluctuating customer load. Now, burden testing is a little more complex. There will always be some burden in the secondary loop of the CT. The wires themselves will inject some burden on the secondary, the test switch, the coils in the meter, and all your interconnects, wherever you connect the wiring. There will always be some burden, but it should be very minimal and negligible. The burden specification that we showed above in this example, 0.3% at burdens of 0.1, 0.2, and 0.5 is essentially saying that the meter manufacturer will guarantee the accuracy of the CT ratio as long as you do not apply more than 0.5%, 0.5 ohms of burden on the secondary. Otherwise stated, there should be no less than a 0.3% change in the secondary current from the initial current reading when up to 0.5 ohms of burden is applied. So burden test units such as our 1047 shown here utilize a series of high accuracy burdens internally. The burdens being a combination of resistance and impedance. The values set forth by ANSI and IEEE are 0.1, 0.2, 0.5, 1, 2, 4, and 8 ohms. So during a burden test, the test unit simply applies additional burden into the secondary loop of the into the secondary of the CT, and takes a measurement of the secondary current prior to the additional burden applied and then afterwards. So graphing this out, you can see the secondary current readings when 0 burden is applied, 0.1, 0.2, 0.5, 1, 2, 4, and 8. And if you graph that out, you should see a plot like this with a definite knee somewhere in the graph. Zooming in here, we can see from the spec up here that we're looking for no less than a 0.3% drop up to 0.5 ohms of additional burden applied. So as you can see here at the 0.5 test point, we still have 4.99 current, amps of current, and therefore the secondary current change is less than 0.3%, and therefore you have a good CT. Now we'll shift over to burden test or admittance testing. So first of all, what is admittance testing? You might or might not have heard this term used. Well, admittance testing measures the general overall health of the secondary loop of the CT. It's measured in millisiemens. Admittance is the inverse of impedance, and impedance is the opposition to current. So what we're doing is measuring how easily current can flow through the secondary of the CT and improving the overall health of that secondary loop. how a CT admittance test unit works. It injects a high frequency audio sine wave signal into the secondary loop of the CT, and then measures the resulting current. The voltage that the unit uses is known. Now the current is known, and from those two parameters, the impedance and thus the admittance can be calculated. Now there's a couple caveats to keep in mind when using admittance testing. The test results are not immediately intuitive. Unlike burden and ratio tests where you get a go, no-go, pass, fail type result, in admittance testing, you need to analyze the results a little bit. So for admittance testing, we recommend a 3-step test process. First of all, test each CT individually. Optimally, it is good if you can test the CT at the time of installation. That might not be available. These could be older CTs in the field, but we recommend testing them just as soon as possible, and then testing them over time, maybe every 3 months, 4 months, 6 months, and checking the new results against the old ones to see if you have any drift. Also, if your reading gives you a short or open, you immediately know that there's some issue, not only with the CT, but with the something in the secondary loop. Also, if you have a matched set of CTs, such as in a 9S meter installation where you have a bank of 3 CTs, if those CTs are of the same manufacturer, the same model number, same ratio, their admittance results should be the same. So, for instance, let's say you test a bank of 3 and you get values back of 12.6 and 12.8, and then suddenly 22.3 for phase C. Well, that can be an indicator that something is wrong on the C phase that would mandate additional troubleshooting. So like I said, the admittance testing, the results are not immediately intuitive. The results need a bit more analysis to know if you have good installation. However, admittance testing is widely used because it is the only no-load CT test method available. Burden and ratio testing, by their nature, mandate that you have 10% of the rated current for the CT to get a legitimate result. Here's a few references for today's presentation. This presentation will be available on TESCO's website a little later on. If you want additional information, feel free to look at these websites that I have here. And now for any questions.
All right, guys, so we will open it up to some questions. And Rob, I take it you are still there, correct? Can you guys hear me?
Hey, Andy, can you hear me?
Yes, there you are. I was wondering if anybody could hear me. So I see, let's see. Oops. Let's see.
I'm not at my computer anymore. Do we have any questions coming in?
I am pulling them up now. And again, if you guys have any questions, you can throw it there in the chat. We will go into more detail with any questions you have now. And we also have another session next week. So as you guys are thinking of your questions, typing them, if it's easier to unmute yourself and kind of give us a shout, that's fine too. I have one coming in now. What % of rated load for legit reading from admittance? I know you said it, but it went right by me. That sounds like me when I'm listening to these. It goes right over my head. So,
Okay.
did you get that?
Yes. Okay. So for burden and ratio tests, the rule of thumb to get a legitimate, accurate results and readings is 10% of the rated load on the CT. So if for any CT, 200 to 5, 400 to 5, 800 to 5, etc., you need 10% on the primary and as well as the secondary. So you need on the secondary 500 milliamps current or higher. I know that that's the industry rule of thumb. I know that some CT testers out there can go lower. Our 1047 can go to about 200 milliamps, but the industry standard is 10%. Beyond 10%, if you get too low, you get down into the noise floor of the signal, and where if you have significant noise down there at that low current levels, it can really mess up your readings. So the rule of thumb for burden and ratio is 10% of the rated current on the CT. As far as admittance is concerned, this is the big benefit of admittance testing. It is the only no-load CT test method. So in specific areas such as Nebraska, Iowa, the breadbasket of the U.S. where you have a lot of irrigation, the irrigation systems might be turned off when you get that work order to go test a meter. And so admittance testing is very beneficial in those applications, as well as oil derricks and oil pumps. They might not be on as well. So the use of admittance testing is somewhat regional, based on its biggest benefit, that it's the only no-load CT test method that we have available.
Excellent. Thank you, Rob. And I think at the same concept, like people maybe absorbing too much information during the presentation there, about demagging, same thing. They're questioning, like, what is it? Like, they kind of heard you, but can you kind of explain that one again?
Yes, absolutely. Okay, so just at an anecdotal level, I have been doing demos and training on various CT test equipment for a little bit over a decade now. And although CTs rarely go bad in and of themselves, they're nothing but a coil of wire, so there's not much to go wrong there. When you do go out to do your testing, you do sometimes get erroneous numbers, bad results from the burden and ratio test. And I would say anecdotally 60, 70, maybe as high as 80% of the time, when you initially get bad numbers from your test, just hitting it with a Demag function, if your test equipment has that available, typically clears up those bad numbers. So I recommend when you go out to a site, you get everything connected, run your burden test, run your ratio test. If you get bad numbers, first thing you should do is hit it with a Demag function. And what a Demag function does is it simulates a varying customer load on the primary of the CT through the secondary. It goes through those burden test points of 0.1, 0.2, 0.5, 1, 2, 4, and 8, slowly and smoothly up and then back down. And like I said, it's somewhat simulating the fluctuating customer load on the primary, which can take a CT out of a magnetized state. And so I would recommend doing your Demag. If you get erroneous results, that's the first thing you should do. Rerun the test. If you still get bad numbers, like I said, 60, 70, even 80% of the time, typically a Demag clears it up. But if you're still getting bad numbers after a Demag, that's when I would start looking for other issues. Miswiring, closed CT shunt, corrosion on the test switch, a meter not set right in the socket, just a number of different issues that could be a part of that secondary loop of the CT. The last place I would look for the root cause of the issue would be the CT itself. Like I said, CTs are, they're just coils of wire. There's not much to go wrong with it. So that's basically what you're doing in when you apply a Demag function.
All right, great. A couple more coming in here, and you guys keep the questions coming. We really appreciate it. The next one is and this goes back, I think, to your first question. We have found at burden measurements that in some burden measurements, but not all of them, the cable has been a big problem, but we weren't able to identify exactly when that would be a problem. Do you have any advice?
When the cable would be a problem?
The cable has been a big problem, but they weren't able to identify exactly like when that would be a problem.
Yes. One of the most common issues that you run into, or errors that you find when doing CT testing in the field, you're testing the CT, but you inadvertently catch a whole bunch of other issues. And one of the primary ones after you do a Demag function that you would catch is miswiring. Specifically, not just connected in the wrong place, but if you use too long of wires or use too small of a wire gauge, you've effectively applied additional parasitic burden on that secondary loop. Thinking back to the slide that I showed earlier with the graph and how we say you initially knowingly incorrectly assume that the initial burden during the test is 0. Well, if you see a graph shifted over, that's a telltale sign that the burden was not 0 and you had excessive initial burden on that secondary loop. And one of the causes of that would be too long of secondary cabling or too small of wire gauge. Most utilities I've seen, they have their own internal standards for the lengths and gauges of that secondary loop. And so if you have those available, my recommendation is always use those when installing your secondaries of your CT down to the meter.
All right, so hopefully that answered the question. If not, Raphael, you can always pop on and ask or unmute and let us know. Let's see, the next one coming in says, you said that admittance test needs to be analyzed. Is there an MS value that would indicate the CT is bad?
The answer to that is no. Unfortunately, the answer is no. Because there are so many different CT manufacturers that have produced so many different model numbers of CTs at various different ratios. There's not one millisiemens value that you can hone in on and say, oh, that's good or that's bad. You can see millisiemens values out of an admittance test of 8, 12, 25. It's a wide range. Just because of the materials and manufacturing processes of all the different CTs that have been produced over the years. That's why we recommend that 3-step process that, step 1 is to test the individual CTs. If you get an open or a short during the admittance test, you know that something is immediately wrong. Either you have an open wire or the CT shunted, you got a short somewhere. But other than that, if you just get a millisiemens value back, then you have to investigate further and take it to steps 2 and 3. Step 2 would be on say a 9S installation where you have a bank of 3 CTs and they're all the same ratio, same model, same manufacturer. They should all have very similar millisiemens value from an admittance test. So if you test each of the CTs in that bank and you get, say, values of 10, 10.2, and 18, that the CT that gave you the value of 18, that's an indicator that something's wrong in that phase. And then lastly, the 3rd step is to test over time. Optimally, you want to test the CT at the time of installation. That is not always available, so you need to test as soon as possible, and then test periodically after that to see if there's any change, which can be a little bit of preventative maintenance, that something's starting to go bad, that you can then do additional troubleshooting and analysis and see what's happening in that circuit and get it cleaned up before it becomes a hard failure.
Okay. And let's see, I'm trying to organize everybody's, and I'm getting some sent privately here, and I'm on 2 different screens, so I might have to shut down the one just to get the chat, because for some reason it's not popping up on the computer. So you might see the screen slide go away for a second. That's me checking the chat. So another question that just came in, how do I test high accuracy 0.15 transformers?
Oh, okay. Yes, the very same way that you would test like a 0.3% CT. But in those cases, instead of looking for a shift of 0.3% as you apply the additional burden, your make or break point is 0.15%.
Okay. Sorry, I'm still going through some of these, making sure I don't miss anyone. You got to thank you for the second to last question there. You guys keep this coming. I am going to get to every one of them. So it's just us managing that chat. So let's see. I think you may have answered this one earlier. When you get bad results from a burden or ratio test, what should I do?
Yes, I covered that earlier. The main rule of thumb is to keep in mind is the last thing you should look at is the CT itself. You will inadvertently find a ton of different issues other than a bad CT. So always look at that last, double check everything else, your wiring, your test switch, meter seating in the socket, etc.
Okay. And I'm going through. Do you guys have any other questions coming in? It looks like someone's typing. And I just want to make sure I'm not missing anybody. And again, if it's easier, feel free to unmute yourself, guys. This is a kind of open forum, very casual. At this point, we kind of did go through the slides pretty quickly. So next week, we're going to go kind of into more detail. It is a two-part series. Let's see. What are some common failure modes seen in the field?
Okay. First and foremost, like I said, magnetized CTs. CTs can be magnetized due to a number of reasons: lightning strikes, temporary open secondaries, harmonics on the line. If you have a fluctuating customer load, the CT can automatically pull itself out of that magnetized state. But if you have a constant customer load, it can stay in that state indefinitely. So first and foremost, look for a magnetized CT. You find a lot of miswired installations, swap phases, reverse phases. Like I said earlier, too long of secondary lines, too small of wire gauges, corrosion on the test switch, meter not set properly, loose connection points. We have found, it's rare, but we have found mislabeled CTs. It'll be labeled, say, 400 to 5, but it's really a 200 to 5. That's where your ratio testing comes in handy to locate those. Like I said, it doesn't happen often, but we found one or two. And wrong multipliers, I need to bring that up. You should always check for wrong multipliers. I'm going to get into that on the multipliers a little more in detail next session, next Tuesday.
Okay. All right. I don't see any more. I hope I'm not missing anybody. I'm scrolling through just to make sure. Do you guys have any other questions for this session?
Yeah, Ross, back to the admittance testing, you were saying like you got a 10, 10.2, and then an 18. If you got that 18 on that third CT, would you replace it and just try to find one that fell in line with the 10, the 10.2 to go forward, like on a 9S system?
Okay. First of all, I would hit it with a Demag and retest just to see if that was the culprit. Then I would check to make sure that I had a matched set of CTs. It could be the case that in the aftermath of a storm, and they were in a hurry, and they grabbed a wrong CT and stuck it in that phase. If a service was damaged during a storm, not really thinking of making sure you match the ratios and having a matched set of CTs. If you don't have a matched set of CTs in regards to manufacturer model, then your ratios could still be good. And so I wouldn't be worried about it, but because they are a different model number, different manufacturer, different manufacturing techniques and materials, you could have differences between the phases for admittance, but it's not really affecting the performance of that installation, and you still have correct billing. Beyond that, like was said in the session, admittance tests the overall health of the CT secondary. So then I would check wiring for corrosion, anything that might be causing additional burden on that loop. And going back to the rule of thumb, look at the CT last, and then if it's still bugging you, yeah, you might go ahead and replace everything so you have a match set. But like I said, there could be cases where you have the right ratios, but they're not of the same manufacturer, same model number, and so your admittance values could be off, but there's no issue with the billing.
All right, thank you. Thanks for the question there, Ross. Let's see here. How often should CTs be tested?
The short answer to that is it depends on how much risk you're willing to assume. Like with all testing, like with meter accuracy testing, if you have a longer period between tests and you go back and do the next test and you find something wrong, if that's a longer period, then you have more time and more monthly bills to worry about were they accurate or not. If you test more frequently, your risk goes down. And that should be based on your utility's periodic test procedures and program. For your high bill, high rate customers, that I would suggest at least once a year. You get down to your smaller residential, or your smaller commercial installations and customers, it's not as important, but I would definitely be picking out like your top 10 and testing those at least yearly.
Okay. I'm going to double check the chat again because I have the two screens going. This is what happens behind the scenes. We always have so much going on here. Does anybody have any questions you guys want to unmute and ask? I don't see any more on the chat. I hope I didn't miss anyone. Let's see. And I know we have a couple of our regional managers on the line today too. I don't know if you guys have anything you'd like to add or anything you've seen or experienced in your work there.
Hey Andy, it's Jim here up in Canada.
Hey Jim, how are you?
Great. We always did a service analysis anytime we changed the meter or there was any alterations to the service whatsoever, or a contractor had been into the switchgear for whatever reason. So, other than that, we did exactly what Rob said, which is we had an annual program where we'd go around and test all the CT rated services, but just a wise thing to do anytime there's been an alteration to the service of any sort or any maintenance done on it over the Christmas holidays or whatever. Good idea to get in there and retest.
Excellent. And then I'm going to share a photo, if I can, that Dan just sent us. Well, there it is sideways. I don't know if I can move it. Let's see here. Oh, it's not letting me move it. So, about CT testing on poles. Dan, do you want to tell us about this one that you were doing?
Yeah, I don't know why the picture got flipped on its side that way. Can you hear me?
Yeah, well, I'll just turn our heads a bit to see it.
in quite a few cases, you find utilities that don't have their CTs mounted in cabinets on the ground somewhere in close proximity to the meter socket with the test switches. You have the CTs mounted up on the bracket. So if you look up by the transformers, just underneath those transformers on that pole, right by that street light, you'll see 3 CTs mounted on a bracket. When you have that situation, you have to use a high voltage probe or a light wire probe that has a fiber optic cable. That orange cable coming down is fiber optic, and then it goes to a module on the ground. It in turn connects to the CT tester that's being used by the gentleman there in front of the meter socket. So what the guy on the left is doing, that you can only see his arm in this particular picture, is he's moving that high voltage probe from one conductor as it exits the CT to the next conductor, and he's testing the CTs down there at the test switch, looking at that primary current, looking at that secondary current, running the burden and ratio test. One of the things I ran into on this site is that bracket up there with the 3 CTs on it. They're not necessarily in logical order. When we were out there testing, we found out that from left to right, it's not A, B, C. There was no particular rhyme or reason to the way they mounted those CTs. So you would put that fork type probe on the conductor exiting that first CT on the bracket and find that that wasn't phase A. It may have been B, it may have been C, but the way to find that is to go ahead and keep moving that duckbill connector on the secondary of the transformer, moving it from one test jack to the next until you find the secondary current that makes sense. If it's not the right CT that you have that high voltage probe on, you'll just get a jumping number. It won't be stable. Once you find the proper conductor, you'll see a nice secondary that matches the ratio. You know, you'll get the ratio, you'll get the primary and secondary current that are relevant to that, whether it's 40 to 1 or 80 to 1 or whatever the case may be based on that CT ratio. You'll see something that makes sense. So that's something you can encounter in the field when you're doing. Now, this is a 2-man operation. The only alternative to this would be a bucket truck, and you'd still need 2 men, one in the bucket, one down on the ground where the test switches are. So testing CTs on poles like this is a bit more of an effort and a challenge. And a lot of times these CTs are mounted in the open air, in the sunlight, so they tend to deteriorate a little more quickly. And reading the information plate on these CTs, unless you have binoculars, and even if you have binoculars, these particular CTs were so washed out you could not read the plates even with binoculars. So that presents an additional challenge because you don't know what the accuracy class is, you don't know what the max burden is. You might be able to read the ratio because that's in big print, but that's one of the problems and challenges associated with testing CTs up on poles like this.
Awesome. Thank you, Dan, for sharing that. Okay, I don't know why it wouldn't turn. I was trying to figure that out, but got the idea from that. And I don't know if anyone else has any other questions, or y'all want to unmute to ask if that's easier. Rob, I think it sounds like you walked into a wind tunnel out there.
Yeah, it's a little breezy where I'm at.
So again, we'll also be continuing this next week. And like Rob said, he'll get more into like multipliers and a little more detail on a lot of these things. If you guys think of questions, you can't wait till next week, you can always reach out to us. We can throw those questions into next week as well. And then let's see, for next week, we have the second part of traditional ratio, burden, admittance, and Demag testing. We'll have the following week, realizing your investment in technology through analytics, and that is through Paul Fratellone, who is our software manager who deals with Meter Manager. So we'll talk about that and how it can help with your, analytics and all that you get from the software. Let's see. Nope, I thought a question was coming in. So on March 30th, we have shop testing. And then going into April, I can't believe it's going to be April soon, preparing for AMI deployment. And that's with Jim McGill. And finishing out this series is going to be communication equipment with John Williams. And he's one of our engineers here in Bristol who is hands-on with a lot of our new products coming out. So hopefully that'll be a super exciting one, and with new technologies they have in the field, as well as old ones that you guys use. So a lot of exciting things coming up for you guys. As always, you can check out our presentations, upcoming ones and past. They're always posted on the website at tescometering.com/TESCO Tuesdays. And we'll just throw a little plug in there. If you like what you guys are doing here with TESCO Tuesday, we have a users group. Things are starting to open up. It is going to be in Philadelphia in July, the 18th to the 21st. And we will be opening registration for that very soon. And we'll be sending information out to you guys. If you're interested, you would have hands-on access to our products and other people networking and things like that. So that's exciting as well. And any other questions you guys have, we'll stick around for a little bit. Otherwise, it's about 10 of here, 9 of, and we'll let you go a little bit early. Thank you so much for joining us once again. We look forward to seeing you next week and hope you all have a great week. We'll stick around if you guys have any questions you want to ask afterward, okay? Thank you, everyone. Oh, here's one coming in now. Is there an ANSI or other standard that defines recommended conductor sizing and lengths in regard to CT or PT circuit burden? Are you still there, Rob?
Sorry, I muted myself because of the wind tunnel.
It got so quiet. That's why I was like...
Yeah, what I was saying is I don't know the answer to that off the top of my head, so I'm requesting that individual's name and email address.
Sure.
I will do some recon and get back with them.
Sure, and we can answer that next week as well with the next session. So
true.
Excellent. And ANSI, okay. Anybody else got any other questions? And Matt asked this question, so we will definitely get back to you on that. And you won't have to wait till next week if we know it ahead of time. We'll email you, we'll reach out, and we will, for the rest of you guys, cover this next week as well. So
yep.
We will do some research on that and get back to y'all. Okay, any other questions, guys? Here we go from Orlando. Let's see. The info for training. Absolutely, we will send that out to you guys as soon as we have that registration open. So definitely send those details to you guys. And I don't see any others. All right, you guys are very welcome. Thank you. We get so. Thank you to Rob for doing this from the road. That was pretty exciting today. Getting back out there for the meter schools. Hopefully, we'll get to see a lot of you out there soon when everything else starts to open up. Thank you to Dan and Jim for throwing in your little bits of info there, and we will see you all next week, I guess. So take care, everyone. Have a great rest of the week, and we will see you next week. Take care, everybody.